Alright guys, I'm not here for lesson 5-2 today, unfortunately. But if you guys take a look at your notes and open up to the lesson 5-2, we're going to talk about using intercepts today. There's two kinds of intercepts that we're going to be working with, an x-intercept and a y-intercept. It's actually not so bad to find them. They're pretty easy to identify. Sometimes doing the algebra takes a little bit of work, but not too bad. So the first vocab word that you have is what a y-intercept is. And what I want you guys to write down for this is that this is the y-coordinate of the point where the graph hits the y-axis. So it's the y-coordinate of the point where the graph hits the y-axis. So because it's a point, I'm going to highlight, let's see here, I'm going to pick a different color. So because it's a point, and this is the y-coordinate that we're talking about, your answer is always going to look like this. So it's a point, so it's going to be parentheses, comma, parentheses. And because we're looking for the y-coordinate, that means that on the y-axis, we're not up or down at all. We're not left or right at all. So your x-coordinate there is going to be 0, whereas your y-coordinate is going to be some number, whatever it is. So I'm just going to leave that blank. So it's always going to look like that. It's going to be 0, comma, something. And the way that you get that is always by plugging in 0 for x and solving. And the reason that we plug in 0 for x is because if you take a look up here, 0 is in the x position of the point. So you plug 0 in for x and then you solve the equation for y. Same thing with the x-intercept. So the x-intercept is just the x-coordinate of the point. So it's a point, the x-coordinate of the point where the graph hits the x-axis. And again, because it's a point, it's always going to look like that form. Something, comma, something, something, comma, something else. And because we're trying to figure out what x is, that means we're not going to know what goes here until we actually solve it, but we're going to be putting 0 in the y position. So when you're going to actually figure out what the x-intercept is, the process is that you do this by plugging in 0 for y and then solving. So basically, if you can plug 0 in and solve an equation, you should be good to go with this entire section. Okay, it's not too bad. All right, so sometimes you will already be given a graph. And if you look at number 1 and number 2, we are already given a graph here. And we're asked to just figure out what the x and the y intercepts are. So you are asked for both of them. So I'm going to have you write x-intercept and y-intercept down because we're asked for two different things. They are kind of unrelated to each other. So it's not like, if one's negative, the other one's going to be negative. If one's positive, the other one's going to be positive. It has nothing to do with that at all. So it's literally you just looking at the graph and picking out where it is. The x-intercept is where it hits the x-axis. And for this graph, it's hitting the x-axis right here at this dot. So our x-intercept is sitting at -4. Now if we write that as a point, I would write it like this, -4, comma, 0, because on the graph it's to the left 4 spaces and it's not up or down at all. So -4, 0 is logical there. The y-intercept is where it's hitting the y-axis, and for us it's hitting right here at that dot. And so that dot is -3 on the y-axis, or you could say it's the point 0, comma, -3. You are going to be asked to write these as a point, so I do want you to get in the habit of writing your answer in this way right here for your x and your y intercept. Don't just write -4 and -3, because I want to know where at -4 and where at -3. Same thing for the next one. So if you take a look, you're asked to identify both of them. So you want to do the x-intercept and you want to be able to do the y-intercept. The x-intercept is where it's hitting the x-axis, and for us it's hitting the x-axis right here at this dot, which is -2. Now the way that I would write that as a point though would be -2, 0. And then it's hitting the y-axis for the y-intercept right up here at the number 3. And the way that I would write that is it's left or right 0 and up 3, so 0, 3. You do have to have your answer written in point form, just like that. Okay. Now, number 2, you'll notice that we don't have a picture. So this, in this way, this is where you actually have to do the algebra. You have to show your work here to actually figure out where the x and the y-intercept are. And the nice part with the x and the y-intercept is if your equation is in standard form, and I'm going to write a little note off to the side with this. If you are in standard form we talked about in lesson 5.1. So if you were to scroll back up to your notes, standard form looks like this. It's ax plus by equals c. And a is just a number, b is just a number as well, and c is also just a number. So if you look at part A and part B here, both of these equations, these are in standard form already because they have a number x, a number y, and then equals a number. So these are both in standard form. If you're in standard form, finding your x and y intercept is really easy because you can use something called the cover up method, where you can cover up a piece of the equation and it easily gets you very quickly your x and your y intercepts with very little work shown, which is kind of nice. So here, I'm gonna start the cover up method here. And what I'm gonna do here is I'm gonna just cover up this first a piece of the equation, or that first x piece of the equation, whatever you want to call it, that ax part. And then if I solve the rest of this equation, all I would need to do to figure out what y is I would need to divide both sides by -2, and then I would get y equals 12 divided by -2 is just -6. So that's my y-intercept. And then if I take that same exact equation, and I'm going to switch colors here, all I'm going to do first is rewrite it, and the equation was 3x minus 2y equals 12. And this time, if I cover up the other piece of the equation, so this part right here, and then I solve the equation for x, all I would need to do is divide both sides by 3, and then I would get x equals 4. And there's my x-intercept. So it's kind of nice because I can quickly get my x-intercept and my y-intercept. My y-intercept is the one that has y equals, so I'm going to label this one as y-intercept. And then my x-intercept is the one that x equals, so x-intercept. So it's not trying to trick you or anything, okay? So for part B then, I can do the same thing. I'm going to cover up the first piece of the equation, and all I need to do then to get y by itself is divide both sides by 5. That cancels those 5s out and gives me that y equals 6. So that right there is my y-intercept. Now if I rewrite the same exact equation that I had up here, the equation was -3x plus 5y equals 30. And now I'm going to cover up the other piece. So if I cover up this piece, the 5y, and then I solve the equation for x, I would just have to divide both sides by -3 for this one. And then I would get x equals -10. Because it's x equals, that's my x-intercept. There we go. That's it. So that's called the cover up method, and it's kind of quick. We use it a lot in both geometry and algebra 2 as well. So, all right, if we take a look at the next problem, number 3 says the Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function f of x equals 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. Graph this function and then find the intercepts. What does each intercept represent? So The fastest way to go about this problem is definitely to get it in standard form first. So I'm going to take the equation that they gave us, which is f of x equals 4,500 minus 300x. And because I have to find the intercepts, getting it in that ax plus by equals c form lets us do that cover-up method and lets us get those intercepts really, really quickly. And you haven't seen this yet, but then it makes graphing it so nice. So what I'm going to do is I'm going to take that equation, and here's the deal. We know that f of x right here, that's the exact same thing as y. All right, so get in the habit of knowing that that means y. That's just function notation. So I'm going to write the equation as y equals 4,500 minus 300x off to the side. All I did was replace that f of x with y because they mean the same thing. And then I'm going to put this in standard form. Right now it's in slope-intercept form. You're very used to slope-intercept form. But to get it in standard form, I just want the x and the y on the same side. So I'm going to plus this 300x over to the left-hand side. That way it moves it over. So then I'm going to write this as 300x plus that y piece that's also on the left, and then equals the 4,500 part of it. So all I did right here is I got this into standard form. And the only reason I put it in standard form is because it makes getting those intercepts, just like the last problem, it makes getting those intercepts so fast. So what I'm going to do is do the cover-up method now. So now that I'm in standard form, I'm going to cover up this first piece and check it out. I don't even have to get y alone. It's already alone. Y equals 4,500. That's my y-intercept. Okay. Now I'm going to take that same equation that I had. Okay, the same equation that I had was 300x plus y equals 4,500. And this time, when I do my cover-up method, I'm going to cover up the other piece. So if I cover up the y piece right there, to get this x alone, all I would have to do is divide both sides by 300. And then that would give me x equals, let's see, if I type in 4,500 divided by 300, that gives me 15. So my x-intercept is 15. Now here's the really cool part about this. The nice part is, when I go to graph this, now I'm only dealing with distances in minutes here, so it doesn't really make sense to do a 4-quadrant graph. I'm not going to be dealing with negative minutes or negative distances at all. So I'm just going to draw a first quadrant graph. They told us what the x stood for, and the x up here, they said stood for minutes. So then I know when I draw my graph that I can label this as time measured in minutes. Okay. Now, my x-intercept is 15. So I have to make my graph at least go up to 15. So I'm going to go 5, 10, 15 over here. All right, and then my y-axis needs to at least get up to 4,500 because that's my y-intercept. So I'm going to make my graph count by, I think I'll just go like 1,000s. So this would be 1,000, and then 2, 3, 4, 5,000 would be up here. I did not label my y-axis yet. Y must stand for, let's see, we're talking about minutes, and then, let's see, the tram's distance in meters, it says. So this what y-axis over here is the distance measured in meters. Okay. Remember that you don't have to label every single tick mark. You just need to let us know basically what you're counting by, and make sure you make it up as far as you need to get all your information on. So my y-intercept was 4,500. I'm going to make sure that right between my 4,000 and 5,000 mark, that'll be my y-intercept right there at 4,500. And then my x-intercept was 15. So over here at 15, I should have a dot as well for my x-intercept. And then all I need to do is connect those with a line. And if I draw a nice straight line connecting those two dots, that is the graph of that line. All right, so we graphed it and we have our intercepts. The last thing that we have to do is say what each intercept represents. So the whole story is about us starting up at the peak of Sandia Peak up at the very top of it, and then we're going down the tram. Let's see, it says we're going down the tram for X minutes or whatever it is. Okay, so here's the deal then. That very first dot at 4,500, that means 4,500 meters because we're on the y-axis. So that would be at 0 seconds, okay, we're up 4,500 meters. So that means for at 0 seconds, that at 0 seconds, that's the same as saying at the start. So I'm going to say at the start, the tram is up at 4,500 meters. That's what that x-intercept represents. Or I'm sorry, the y-intercept, sorry. The x-intercept is my orange dot over here at 15, and the x-axis stands for time in minutes. So that point is 15, 0, and 15 is the minutes. So then we're going to say at 15 minutes, and then the tram goes down, 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 down because the line's going down. And so it must take 15 minutes for it to get all the way to the end because that point is 15, 0. So that's 15 minutes in 0 meters. So I'm going to say at 15 minutes, the tram makes it to the bottom. Because the bottom would be 0 feet. Now you could totally say at 15 minutes, the tram makes it to 0 feet or meters. Okay, you could totally say at 0 minutes, the tram is up at 4,500 meters. That's okay to say. I just know at start means 0 minutes and the bottom means 0 meters. Okay, so just another way to say that. All right, I think that's all we have to do for that one. Take a look at number 4. The school store sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens x and notebooks y that you can buy for $60. Graph this function and find the intercepts and then say what each one of them represents. The nice part is for this equation, it's already in standard form. So what we can do with this is right off the bat, we can get those intercepts really easily. 2x plus 3y equals 60. That looks just like ax plus by equals c, okay? Which means we can do our cover-up method right now. I'm going to cover up the 2x part. To get y alone, I divide both sides by 3. This gives me my y-intercept. If I do 60 divided by 3 in my calculator, that gives me 20. All right, so that is my y-intercept. All right, then I can take my exact same equation from right there. I can write it again, 2x plus 3y equals 60, and this time I can cover up the other piece. So this time, if I cover up the 3y, I can get x alone by dividing both sides of the equation by 2. That gives me x equals, and that would be 30. That's my x-intercept. So I got my intercepts, which means that I can very quickly graph this as well. We're talking about selling notebooks and pens, so again, I'm going to do a first quadrant graph because we're not going to be able to sell negative notebooks or negative pens. My x and my y, let's see, they told us up here that pens was the x and notebooks is the y. So when I label, I need to make sure that I put pens on the x-axis, and on the y-axis, I need to put my notebooks. Now, my y-axis has to make it up to at least 20, so I'm going to count by I'll count by 5. So I'll go 5, 10, 15, 20. My pens, my x-axis, let's see, my x-intercept is 30, so I have to at least make it up to 30. I'll probably count by 5s again here. I'll go 5, 10, 15, 20, 25, 30. There we go. All right, so I need my y-intercept on there at 20 because that's what we got here for our y-intercept. My x-intercept was 30, so I need a dot at 30 on the x-axis. And then I just need to draw a line connecting them together. And there it is. The only other thing that we need to do is say what each of them stand for. So my first one right here, my y-intercept that I put in green, that one is, let's see, left 0. So that means 0 pens are sold. So if 0 pens are sold because the X would be 0 there. Then 20, let's see, that would be Y as my notebook, so 20 notebooks are sold. Okay, for my other point, that would be right here that I did in pink. That's the point 30 on the x-axis, which is up or down 0 on the y-axis. So I would say if 30, that's pens on the x-axis, if 30 pens are sold, then 0 notebooks are sold. Okay? All right, so we graphed it, we found the x and y intercept, and we described them, so we're all set here. All right, last problem here, guys, then I'll set you free. Number 5 says use the intercepts to graph the line described by each equation. And we just need to find the intercepts, to graph it. Okay, so the nice part is part A is in standard form already, so that's really, really nice. I'm going to even write a little note here that says standard form, because when it's already like that, this makes it so much nicer for you. Cover up that x part and then get y alone. We just divide by -4 on both sides. That gives us y equals 8 divided by -4 is -2. That's your y-intercept. Okay, rewrite your equation. The equation was 2x minus 4y equals 8. Now cover up your other piece. So if I cover up the -4y part of this, to get x alone, I would just need to divide by 2 on both sides. That gives me x equals 4. So I've got my x and y intercepts. To graph this off to the side here, let's see, I'll count by 5s here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, my y-intercept was at -2, so on the y-axis I need to go down to 2. This is my y-axis. My x-axis I need to go over to 4, put a dot there on the x-axis, and then you draw a line through them. Done. Not bad. Okay. After that, part B, we're going to do the same thing, except this one's a pain in the butt because it's not in standard form yet. So if it's not in standard form, you're going to get it in standard form. So I'm just going to make a note here that says not in standard form. Standard form just means the x piece and the y piece are both on the same side. And I like them on the left-hand side just because that's the way we typically see that. So to get this x piece right here over on the other side, I would need to undo that. So I would do plus 1/2 x. That way it moves it over and gets it out of here. So if I rewrite this, it gives me 1/2 x plus, that's 2/3 y, and I have equals 4. All right, so now it's in standard form right here. That lets us do that cover up method really, really nicely. So I'm going to cover up the first piece. To get y alone, this one does have a fraction, which is kind of messy, but remember, to get rid of a fraction that's being multiplied by something, you just times by the reciprocal. So I'm going to write times by 3/2 on both sides. 2/3 and 3/2 undo each other. So y equals 4 times 3/2, if you type that in your calculator, is 6. So my y-intercept is 6. Now if I take that same exact equation that I had up there and I write it down again, 1/2 x plus 2/3 y equals 4, and this time cover up your y piece of the equation right there. We can get our x alone by timesing by the reciprocal of 1/2. The reciprocal of 1/2 is 2, or you could even write 2/1. It doesn't really matter. 2 is the same as 2/1. 1/2 and 2/1 undo each other. So that leaves me with x equals 4 times 2, or 4 times 2/1. Either way will get you 8. And that's your x-intercept. So when we go to graph this, x and y, let's see, I'm going to count by 2s, 2, 4, 6, 8. And I'll do the same thing for my y's. 2, 4, 6, 8. 2, 4, 6, -8. There we go. My y-intercept is 6, so I'm going to count up 2, 4, 6. There's my y-intercept. My x-intercept, I'm going to count to the right over to 8 here. There we go. And then we can draw a nice straight line between the points. And that's my graph for part B. That's the end, guys. Hope it went well. Have a good rest of your day, and I will hopefully see you all tomorrow.